Good day. In my presentation today, I want to address a question that's been on my mind the last number of years. And the question I want to address is, in respect to herbicide resistance, have I oversimplified my message? As you will note in my presentation, I've typed the words using a third-person pronoun, but I'm going to read them using a first-person pronoun because I do not want to make the assumption that everybody else has simplified their message the way I have. So the question that I'd like to address is, in my quest to simplify my message with respect to herbicide resistance, am I misleading agronomists, ag retailers, and producers? So, with respect to herbicide resistance, university professors, weed scientists, extension agents, and personnel from the agricultural companies are conservative and err on the side of caution. So the question is why? So university professors, weed scientists, extension agents, and personnel from the agricultural products companies' reputation is on the line in all their communication. My respect from producers depends on them getting commercially acceptable weed control. And therefore, I simplify my message to ensure producer success. This happens to be the front panel from the Atrex label in Canada. And you will note that on the front panel, it states that Atrex or atrazine is a group 5 herbicide. And on the Canadian label, if you go to section 14 of the label, the title is Resistance Management Recommendations. And the text is to delay herbicide resistance, where possible, rotate the use of Atrex liquid 480 herbicide or other group 5 herbicides within a growing season or sequence or among growing seasons with different herbicide groups that control the same weeds in a field. And I will show you that laboratory, greenhouse, and field research conclude that herbicide resistance is far more complex, or you could say nuanced, than that. Research has shown that in many cases, herbicide resistance is specific to the chemical family within a herbicide group, active ingredient, mechanism of resistance, amino acid substitution, application timing, and temperature at application. And herbicide resistance is not herbicide group specific. So my concern is because I have dramatically oversimplified my message, I have removed very successful, useful herbicides and reduced grower success. So in this presentation, I will use 10 examples from Ontario, supported by research from around the globe, that in many cases, it is an oversimplification to simply say weed biotypes are herbicide group resistant. The first example that I will use is group 4 resistance can be active ingredient or herbicide family specific. So this is research that was published in 1963 on the very first herbicide-resistant weed biotype documented on the globe. And it happened to be near Milton, Ontario. And this is what the researchers found. So here they were looking at wild carrot injury, and notice where they applied the sodium salt of 2,4-D, the amine salt, and the ester salt at 5 to 6 weeks after application, the injury rating was 0. So these weeds were obviously resistant to 2,4-D. What absolutely amazes me, in the exact same study, they applied 2,4,5-T, another phenoxycarboxylate group 4 herbicide, and the wild carrot was susceptible. So the authors wrote, and I took this straight out of the manuscript, when treated with 2,4-D, plants of the susceptible strain died within a few weeks, while those of the resistant strain recovered after showing severe injury symptoms. And the authors went on to write, treatment with 2,4,5-T killed both the susceptible and resistant strains. So if you look at the caption on my slide, it says group 4 resistant wild carrot, and that's wrong. It is actually 2,4-D resistant wild carrot, and some phenoxycarboxylates still control this resistant biotype. Furthermore, with group 4 resistant weeds, my caption is group 4 resistant Palmer amaranth, and a population of Palmer amaranth from Kansas is resistant to 2,4-D and MCPA, the phenoxycarboxylates, as published in 2021 and 2023. But really interesting, the authors went on to say that it was sensitive to dicamba, a benzoate herbicide within the group 4 herbicides. So once again, if you look at the top of my slide, I typed group 4 resistant Palmer amaranth, and that's incorrect. It is actually phenoxycarboxylate resistant Palmer amaranth, and it is susceptible to a benzoate, another group 4 herbicide in that herbicide group. So in reality, group 4 resistant weeds can be active ingredient specific, as I showed with wild carrot, or it could be herbicide family specific, as I showed with Palmer amaranth. The second example I'll discuss is group 5 resistant lamb's quarters. And I will go on to say that the above caption is inaccurate. It is an oversimplification. This was the manuscript that was published in 1976 by two people in Ontario, Dr. John Bandine and Doug McLaren. And once again, I took these statements straight out of the manuscript that they published, and they wrote, the possibility of weeds becoming resistant to repeated treatment with herbicides was pointed out by Harper in 1956, and the need for rotations was suggested by Abel in 1954. The authors wrote, the authors received a report in August 1974 that atrazine had failed to control lamb's quarters in field corn on a farm located near Ripley in Bruce County, Ontario. And they went on to write that field corn had been grown continuously for approximately 10 years in this field, and atrazine was the only herbicide used prior to 1973. So many people listening to this podcast will think, well, that wasn't very good crop weed management, growing continuous corn and only using atrazine. What you need to realize is that there had never been a herbicide resistant weed biotype in a cornfield anywhere on the globe prior to 1973. So I'm making the assumption that this farmer made a business case, and he found out that for his farming operation, he could maximize farm profitability by growing continuous corn and using atrazine for weed control. The two herbicides that were included in this study were atrazine and metribuzin. Atrazine is a triazine herbicide sold under the trade name of Atrex, and based on the weed control ratings in the Ontario Crop Protection Hub, it provides 95% control of lamb's quarters. And similarly, the triazinone herbicide metribuzin, sold under the trade name of Sencor, also provides 95% control. In the results section of this manuscript, the authors wrote that plants from the Elora selection, so that's the susceptible biotype, were completely killed by applications of the symmetrical triazines, for example, atrazine. They went on to write that plants from the Ripley selection, the resistant biotype, were not killed by atrazine. And really interesting to me, they wrote the H-symmetrical triazinone metribuzin, such as Sencor, killed both selections. So once again, if you look at the caption at the top of the slide, it says group 5 resistant lamb's quarters, and that's inaccurate. This is actually triazine resistant lamb's quarters, and it's sensitive to the triazinone metribuzin. So just a few summary comments on group 5 resistant lamb's quarters. In Ontario, lamb's quarters is resistant to atrazine but sensitive to Sencor and Lorox, and more accurately, it should be called triazine resistant lamb's quarters. In Germany, a lamb's quarters population with the leucine 218 valine substitution is resistant to Sencor but sensitive to the triazines, the complete opposite of what we have in Ontario. And that biotype is metribuzin resistant lamb's quarters. And very interesting, in Prince Edward Island, a lamb's quarters population with the serine 264 glycine amino acid substitution is resistant to Sencor but sensitive to the substituted urea, Lorox. And more accurately, it should be called metribuzin resistant lamb's quarters and not group 5 resistant lamb's quarters. The third example I'll discuss is group 4 resistant green pigweed. And once again, the above caption is inaccurate. It's an oversimplification. So here you can see the weedy control in from a farm in Kent County, Ontario. And in research conducted by my colleague, Dr. Isabel Aiklin, she found that this biotype was resistant to MCPA and had a resistance factor of 4.4. Really interesting, in Isabel's research, she found that dicamba was still effective. So once again, the caption is incorrect. It shouldn't be group 4 resistant green pigweed. It's actually MCPA and a couple other group 4 herbicides resistant green pigweed, but it's sensitive to the group 4 herbicide dicamba. So in reality, group 4 resistant green pigweed is active ingredient specific within the group 4 herbicides. The fourth example I'll present is group 2 resistant green pigweed from Ontario. And once again, the above caption is inaccurate. It is an oversimplification. There are 7 herbicide groups within the group 2, 7 herbicide families within the group 2 herbicides. They are the imidazolinones, the triazolopyrimidines, as well as the sulfonylureas. Within the imidazolinones, you have imazamox and imazethapyr, sold under the trade names of Raptor and Pursuit. Within the triazolopyrimidines, there's chlorantzalam methyl, or first rate, and flumetzalam python. And the sulfonylureas, you have herbicides like Classic, Hermit, Peak, as well as Harmony. So what's known today is that there's amino acid substitutions that occur at 8 different sites on the ALS gene, and they confer 29 different amino acid substitutions at those 8 sites. And so this is a manuscript that was published by Gabe Ferguson in 2001. And this is the first manuscript of a group 2 resistant weed in Canada. So the Hero biotype was the susceptible biotype and was arbitrarily given a value with a resistance factor of 1. Really interesting to me, the Brigden 29 biotype was highly resistant to the imidazole-known herbicide Pursuit and the sulfonylurea herbicide Harmony, with a resistance factor of greater than 1,000. But even more interesting to me was the Brigden 39 biotype. It was highly resistant to the imidazole-known herbicide Pursuit, but it was very sensitive to the sulfonylurea herbicide Harmony. So once again, this is an oversimplification. And I would ask you, do you think it's responsible for me to recommend the Group 2 herbicide Harmony on the Group 2 resistant Brigden 39 biotype? And in this research conducted about 20 years later, Group 2 resistant green pigweed with the serine 653 threonine amino acid substitution, it's resistant to the imidazole-known herbicide Pursuit. It's resistant to the triazolopyrimidine herbicide First Rate. It's resistant to the sulfonylurea herbicide Classic, and it's sensitive to the sulfonylurea herbicide Harmony. So this is similar to the Brigden 39 biotype. And I would ask you, is it okay for me to say to Earl Algae that he has Group 2 resistant green pigweed in his identity preserved soybean when I know that Harmony still works? Now I'll go on to Group 5 resistant water hemp. Once again, the above caption is inaccurate and it's an oversimplification. So there are two amino acid substitutions in water hemp that confer resistance to the Group 2 herbicides in Ontario. The first amino acid substitution is a tryptophan to leucine amino acid substitution at position 574. And if you have this amino acid substitution on your farm, it would confer resistance to the imidazole-known herbicides, Pursuit and Raptor, the sulfonylurea herbicides, Classic, Harmony, Permit, and Express, and the triazolopyrimidine herbicides, First Rate and Python. So in this research conducted by Lauren Benoit, while she was a graduate student in my program, if you have the tryptophan to leucine amino acid substitution, it conferred resistance to all three Group 2 herbicide families that she evaluated: the imidazole-known herbicide Pursuit, the sulfonylurea herbicide Classic, and the triazolopyrimidine herbicide First Rate. In contrast to that, if you have a serine to asparagine amino acid substitution at position 653, it confers resistance to the imidazole-known herbicides Pursuit and Raptor, but the sulfonylureas and the triazolopyrimidines are still effective. So what does this mean on the farm? If you're the unfortunate farmer that has the tryptophan to leucine amino acid substitution at position 574, it confers resistance to the sulfonylureas, the imidazolones, and the triazolopyrimidine. So all 8 of these herbicides listed fail. In contrast to that, if you're the lucky farmer and you have an serine to asparagine amino acid substitution at position 653, it confers resistance to the imidazole-known herbicides, but the sulfonylureas and the triazolopyrimidines still work. So I would ask the question, is it okay for me to say to an identity preserved soybean grower, so that's not Roundup Ready, non-GMO soybean in Ontario, which is about 20% of the market, who has water hemp with the serine 653 asparagine amino acid substitution, that he has Group 2 resistant water hemp, when I know that 6 out of the 8 Group 2 herbicides listed on this slide still work? In reality, Group 2 resistant water hemp is amino acid substitution and herbicide family specific. The sixth example that I'll give you is Group 14 resistant green pigweed in Ontario. And the above caption is inaccurate. It's an oversimplification. Within the Group 14 herbicides, there's two soil-applied herbicides. There's the N-phenyltriazolinone, sulfentrazone, sold under the trade name of Authority. And according to the Ontario Crop Protection Hub, it provides 95% control of pigweed species. And then you have the herbicide family, the N-phenylimides. The active ingredient is flumioxazin, trade name is Valor, and once again, it provides 95% control. However, field research in Ontario shows that Authority provides only 7% control of this biotype, and Valor provides 78% control. So once again, to show you what it looked like in the field, in our field research, here's Authority on Group 14 resistant green pigweed and near perfect control with a different Group 14 herbicide applied to the soil. So I say there is Group 14 resistant green pigweed when I know that Valor, a Group 14 herbicide, provides very good control. The seventh example is glyphosate-resistant horseweed, and its resistance is influenced by both temperature as well as by mechanism of resistance. Within Ontario, there are two mechanisms that provide glyphosate resistance in horseweed. There's an altered target site. It's a proline to serine amino acid substitution at position 106, and vacuolar sequestration. So in terms of vacuolar sequestration, glyphosate can be sequestered in the vacuole or extracellular space, which prevents it from being translocated to the site of action. In horseweed, the amount of glyphosate in the vacuole in the susceptible biotype is only 15%. That means 85% of the absorbed glyphosate can be moved to the chloroplast. That's where the shikimate biosynthetic pathway occurs, and it stops the production of aromatic amino acids, and the weed dies. That's how glyphosate killed all weeds on the globe prior to the evolution of glyphosate-resistant weeds. Really interesting, in horseweed, in the resistant biotype, 85% of the glyphosate is sequestered in the vacuole. Insufficient glyphosate goes to the chloroplast, and you have a resistant weed on the farm. And the sequestration is in the vacuole is via ABC transporters. Really interesting. Temperature has been found to affect vacuolar sequestration of glyphosate in horseweed. And when glyphosate was applied at less than 12 degrees Celsius, 54 degrees Fahrenheit, vacuolar sequestration of glyphosate was inhibited, and the resistant biotypes were susceptible to that treatment. So in Ontario, if the mechanism of resistance is vacuolar sequestration, and you sprayed on April 15 when the temperature was 8 degrees Celsius outside, glyphosate would control this glyphosate-resistant horseweed. So if horseweed is resistant to glyphosate due to vacuolar sequestration and it's applied at less than 12 degrees, then glyphosate is still effective. Really interesting though, if in contrast, if resistance is due to an altered target site, there is no effect of temperature. The eighth example I'll go through is Group 27 resistant water hemp is influenced by time of application. So the above caption is an oversimplification. Group 27 resistance in water hemp is due to enhanced metabolism, which confers resistance to the Group 27 herbicides applied post-emergence. But really interesting, The group 27s applied prior to water hemp emergence still work. So this is research that was conducted by Hannah Symington while she was a graduate student in my program. And she was the first person to document group 27 resistant water hemp in Ontario. You can see where the group 27s were applied post-emergence. Callisto, this plant obviously survived the application. It's resistant to Callisto applied post-emergence. It's resistant to atrazine applied post-emergence, and it's resistant to the tank mix of Callisto plus atrazine applied post-emergence. Hannah also did evaluations where the herbicides were applied pre-emergence. So she put 100 water hemp seeds in each one of these flats. Here you can see the control. The water hemp emerged where atrazine was applied pre-emergence. You can see that it was resistant. Really interesting to me. This is seed collected from the exact same farm in Ontario. In the previous slide, I showed you that Callisto totally failed, applied post-emergence, and Callisto, the same herbicide applied to the soil, provided 100% control, as did the tank mix of Callisto plus atrazine. So what does this mean on the farm? If the mechanism of resistance is enhanced metabolism, uh, the group 27s applied post-emergence, Armazon, Callisto, Laudis, and Shieldex are resistant. They don't provide any control. In contrast to that, on the exact same farm, the group 27 herbicides applied to the soil, Acuron Balance and Callisto provide control. And I would ask you the question, is it okay for me to say there is group 27 resistant water hemp when I know that the group 27 herbicides, Acuron, Balance, and Callisto, applied pre-emergence, provide excellent control? The ninth example is the intersection between chemical structure and mechanism of resistance for group 5 resistant water hemp is fascinating. And once again, the above caption is an oversimplification. There are two mechanisms that confer group 5 resistance in water hemp in Ontario. The first one is a non-target site resistance via enhanced metabolism, and there's target site resistance and an amino acid substitution. So non-target site resistance is due to enhanced metabolism, and it's by glutathione S transferase that conjugates with the herbicide atrazine. That conjugated herbicide is recognized by ABC transporters. It's dumped into the vacuole, and you have a resistant biotype on the farm. So it confirms a high level of resistance to atrazine, but metribuzin, another group 5 herbicide, is still effective. So this happens to be Doug Nelson's farm in Essex County, quite close to the US border in Ontario. Here, atrazine was applied and it completely failed, as I explained earlier. What absolutely amazed me on this farm, this soybean experiment was done adjacent to the corn experiments. Atrazine fails and Sencor provides 100% control of what I called a group 5 resistant water hemp. So it all comes down to chemical structure and the mechanism of resistance. Atrazine has a chlorine at the number 1 position on that 6-member ring. This chlorine provides a binding site for glutathione S transferase. The conjugated atrazine is recognized by ABC transporters and it's dumped into the vacuole. In contrast to that, metribuzin has an oxygen at the number 1 position on that 6-member ring. That oxygen does not provide a binding site for glutathione S transferase, so the herbicide remains active and it provides 100% control on Doug Nelson's farm. But there's a second mechanism of resistance that confers resistance to water hemp in Ontario, and that is an altered target site. It's a serine to glycine amino acid substitution at position 264, and this confers resistance to the triazine herbicide atrazine and the triazinone herbicide metribuzin, or Sencor. So if you look at the control with Sencor, you saw the slide earlier. This is Doug Nelson's farm. The mechanism of resistance is enhanced metabolism, and Sencor provides 100% control on his farm. Whereas in contrast to that, this is Tony Stratman's farm. It's about 100 kilometers away, 60 miles. The mechanism of resistance is an altered target site, and Sencor totally fails. So I've shown that the mechanism of resistance will impact whether Sencor works or does not work on the farm. So the mechanism of resistance influences field performance with Sencor. So what does this mean on the farm? If you're the unlucky farmer and you have the glycine to serine amino acid substitution at position 264, it confers resistance to the triazine herbicide atrazine and the triazinone herbicide Sencor. In contrast to that, if the mechanism of resistance on your farm is enhanced metabolism, atrazine fails, and Sencor, as I showed, can provide near perfect control. And I would ask the question, is it okay for me to say to Doug Nelson that he has group 5 resistant water hemp when I know that the group 5 herbicide Sencor provides excellent control on his farm? So I say there's group 5 resistant water hemp to simplify my message to ensure grower success, even though I know that it's affected by chemical structure and mechanism of resistance. And the last example I'll give is the group 1 resistant large crabgrass. And once again, the above caption is inaccurate. It's an oversimplification. Within the group 1 herbicides, there's 3 herbicide families. You have the DEN, which is pinoxidin, sold under the trade name of Axial. You have the cyclohexane diones. The active ingredients are clethodim, sethoxydim, and tralcoxydim, sold under the trade names of Select, Post, and Achieve. And Select and Post are given a rating of 85% for crabgrass control in Ontario. And you have the aryloxyphenoxypropionates called the FOPs. The active ingredients are phenoxyprop, fluazafop, and quizalofop, sold under the trade names of Ristar, Fusilade, and Assure. And once again, Fusilade and Assure in Ontario are given a rating of 85% for crabgrass control. So this is some research that we did at the highest labeled rate of Assure in Ontario. This is crabgrass seed collected from Waterloo County in Ontario. Assure was applied and 100% control in the greenhouse, and the selection from Huron County, Earl Becker's farm, and it failed. And that didn't surprise me in our greenhouse research. Earl Becker told me that Assure failed on his farm, and our greenhouse research supported that. And we looked at a dim herbicide Post, and once again, the Waterloo County biotype, it was controlled with Post, and the Earl Becker's farm Post failed on that selection, similar to what I just showed you with Assure. What really surprised me in our greenhouse research was that Select at 75 milliliters per acre, it controlled the Waterloo County biotype and the Huron County biotype. So here I'm showing you that 2 group 1 herbicides failed on the Huron County biotype, but Select still worked. So then we did a field study this is post, identical to our greenhouse research. It totally failed in the field. And select provided near perfect control. So if you look at the chemical structure of both post and select, I put this purple bar over here. Everything to the left of that purple bar is identical in both post and select. And it is really subtle differences with the substitution at the 2 position on the ring. If you compare the post to select, the substitution's a little more complex in select, and that substitution is not affected by this mechanism of resistance, and select provides near perfect control and post fails. And I would ask the rhetorical question, is it right for me to say to Earl Becker that he has group 1 resistant large crabgrass in his identity preserved soybean when I know that the group 1 herbicide select will provide excellent control on his farm? So in summary, I say there are weeds that are resistant to various herbicide groups to simplify my message to ensure grower success, even though I know that this is not always accurate. And consequently, I am eliminating very effective weed management tools for affected farmers. So my questions for you: is it responsible for me to simplify my message to the extent that effective weed management tools are removed and grower success is negatively affected? Are you comfortable with my communication with respect to herbicide resistance? And due to the complexity of herbicide resistance, can this complexity be effectively communicated to producers? I think we should continue to be conservative in our message regarding herbicide resistance and assume a weed biotype is resistant to all herbicides within a herbicide group, except where through advances in weed science and specifically genomics, the mechanism of resistance and efficacy of active ingredients within a herbicide group are known. It is responsible weed management to use efficacious herbicides within that herbicide group to improve weed control, reduce weed seed additions to the soil seed bank, and thereby reduce the future evolution of herbicide resistance. So, just to give you an example, a few assumptions. A grower has a 3-crop rotation of corn, identity preserved soybean, so non-Roundup Ready soybean, and wheat. The time horizon is 5 cycles of the above rotation, or 15 years. The grower conscientiously incorporates integrated weed management practices into his program. He has a 3-crop rotation, narrow row soybean, cover crop that he seeds after winter wheat combining, and so on. Personally, I think it's responsible herbicide stewardship for Earl Becker to use the Group 1 herbicide Select 5 times in a 15-year period for the control of Group 1 resistant large crabgrass, where the mechanism of resistance is gene overexpression. Also, I think it's responsible herbicide stewardship for Doug Nelson to use the Group 5 herbicide Sencor 5 times in a 15-year period for the control of Group 5 resistant water hemp, where the mechanism of resistance is enhanced metabolism. And I think it's responsible herbicide stewardship for Craig King to use the Group 27 herbicide Acuron applied pre-emergence 5 times in a 15-year period for the control of Group 27 resistant water hemp, where the mechanism of resistance is enhanced metabolism. So thank you very much.